Okay, we got some more problems on geometric sequences. Fairly basic. We go through them or show them to you. I'm going to pause the video and try these. Okay, let's look at these. I'm using some basic formulas here. There's the fifth one there. So we looked at these formulas earlier. Didn't really do much with them other than basic stuff with sequences. But you have the formula here for the nth term of a geometric sequence. A sub n is equal to a1. a1 is the first term. And that's multiplied by r to the n minus 1. R is the common ratio. That's what you're multiplying by to get the next term. Or remember, if you take any consecutive terms of the geometric sequence and form a ratio, it's constant throughout. You get the same number. If you want to add the first n terms of a geometric sequence, so you have your summation formula, and that breaks down or simplifies to a1, where a1 again is the first term, and it's 1 minus r to the n. R is the common ratio over 1 minus r. R is not 0, cannot be 0 or 1. Then later on we'll look at infinite geometric series. Okay, so let's look at the first one. It says find the fifth term and the nth term of a geometric sequence if the first term is 6 and the common ratio is -2. So the nth term sets up this way, a sub n, and its first term, which is given to be 6 here. So this will be 6 times, and it's always the common ratio, which is given here to be -2, so I'll put this in parentheses, to the n minus 1 power. Again, in these problems, n is understood to be a positive integer or a counting number, usually starting with 1. a1 is your first term. Okay, so this is the formula for the nth term. So with this, you can get any particular term of the sequence that has first term of 6 and common ratio of -2. So it wants the fifth term also, so n is 5. a5 then will be 6 times, and replace the n by 5. 5 minus 1 is 4, so that's -2 to the 4th power, and then we just multiply this out. -2 to the 4th power gives me 16 times 6, 96. So that's the solution to problem 1. Okay, the next one, we want to find the nth term, a sub n again. But see, in this case, they don't give you the first term. They give you the sixth term. It's equal to 243, and the common ratio is -3. So we know that the nth term, the formula for the nth term in general is a sub n, and then it's the first term times r, common ratio, to the n minus 1. So here we know the sixth term. We don't know the first term. We know the sixth term, so we can just say a6, a sub 6 is equal to, we don't know the first term at this point, a1. We know the common ratio, though, is -3. I put a 6 where the n is there, so that'll be 5. So now from this, we know a6 is 243. a1. And then here we got -3 to the 5th power. That's a -243. So from here we can find a1. We divide both sides by -243, and we get a1 is equal to -1. So now we can write out the formula. It just wants the formula for the nth term. So a sub n we equal to the first term, that's a1, which is -1, times the common ratio to the n minus 1 power. Now if you want any other term of the sequence, you want the 10th term, just plug in 10 where the n is and do the calculations, and you have it. This one here, we want to find the sum of n equal 1 to 10, 3 to the 2n. So this is geometric. Remember, for a geometric sequence, you're multiplying the preceding term to get the next one. So if I let n equal to 1, this can be 2 to the first, 2 times 3, 6. If I let n equal to 2, it'll be 2 to the second is 4 times 3 is 12. So we're multiplying by 2 to get the next one. So 2, the first term, is 6, and the common ratio equals to 2. Now the formula for the sum of the first 10 terms, so this is what this is, summation here. So we want the sum of the first 10 terms of this. Now we could do this manually and just list them all and then add them. But sometimes n is going to be large, 50. You don't want to list them all. So you just do it this way. One way to do it would be like this. So the formula for this, so it's the first term, which in our case is 6. And that's times, in the numerator we have 1 minus r is 2, to the n power, in this case, going from 1 to 10, so this will be 10. And then in the bottom we have 1 minus r of the formula. So it's 1 minus 2, that's negative 1. Now we can use a calculator here. So let's do it this way. So we got 1 subtract, I'm going to do the numerator first. 1 subtract 2 to the 10th power. I get this. I'm going to multiply that either way here. I'll say times 6 and then divide by negative 1. So you can see this is just going to give me 6,138. That's the sum of the first 10 terms. Now sometimes in the exercises they might ask you to use a calculator. It could be large values or whatever. So let's look at this problem now. Look at math here. And then this one is summation. So let's put summation here. So this is x equal to 1. This is to 10. 1 to 10. And then into the formula here. So it's 3, and that's times 2 to the n power. I'm using x in this case. Doesn't matter, just a variable. Hit enter, and I get the same thing, 6138. Find the sum. So let's look at this one. Here they write it instead of a summation notation, they write it this way, manually here. So 1/4 plus 2/4 plus 2 squared over 4. So to use the formula here, got to find the first term. So it should be clear to you that the first term of this geometric, and it is a geometric, always have to be careful because you could have an arithmetic and you get exercises where they mix it in. Make sure you know what you're dealing with. Here you're multiplying by 2. Every term, preceding term multiplied by 2 to get the next. So it is geometric. So the first term is 1/4. And the common ratio is 2, because you're multiplying by 2. 2 times 1/4 is 2 over 4. 2 times 2 over 4 is 2 squared, and so forth. They don't reduce it here, so you can see the pattern a little bit easier. So this is 2. And then here we want the sum, except they don't give you the actual value of n here, so you just have to take it the way it is and say this is going to be, according to the formula, it's the first term, so this is 1/4. And then up here, it's 1 minus common ratio taken to the nth power, n is the value we want. It's 1 minus 2 to the n, and that's going to be over 1 minus r. 1 minus r, r is 2. So here, 1 minus 2 is negative 1, so we can just bring the negative 1 over here with the 1/4. So this is going to be negative 1/4 here. And this is 1 minus. Now if they give you the value of n, then you would just plug into this formula, use your calculator, and you have your answer. But in this case, we leave it in this form. Find the sum. So you can see that if I let n be 1 here, I get 2/3. If I let n be 2, I get 2/3 squared. and so on. So you can see that the first term is 2/3, and the common ratio is also 2/3. That's what we're multiplying by. So again, in this one, since we don't have actual limits on this one, we're going to express the answer again in terms of a variable. So the sum is equal to, going to the formula, is the first term, that's 2/3, and it's 1 minus 2/3 to the n. This is going from k equal 1 to n, so this is to the n, and that's over 1 minus 2/3. 1 minus the common ratio. 2/3 is the common ratio. So 1 minus 2/3 here is just 3/3, so this will give me 1/3. These can be reduced. 2/3 divided by 1/3 will give me 2. So I can write this as 2, and parentheses, 1 minus 2/3 to the nth. And again, we leave it in terms of n because they don't tell us. They tell you k equal 1 to 5 or to 6 or whatever, then you can go ahead and plug it in and compute it. But in this case, we leave the answer in this form. Thanks for watching. We'll see you next time.